Hello friends, let's do some examples from GRE 503 linear graphs number 1. And let's see, number 1, we want to be able to write the equation of the following graphs in slope-intercept form. Slope-intercept form is just a fancy way to say y equals mx plus b, which is a type of equation we're very familiar with. So to write this equation, I need a slope. We know how to find a slope from a graph. I just pick out two nice points where they cross at it's called a lattice point when it crosses at a nice spot like that. My rise over run would be 1, 2, 3. My run is 1, and this is a negative slope. So my slope would be negative 3. I multiply that by the x, plus this b value is the y-intercept. Looking at this graph, I see the y-intercept. Here's the y-axis, and the y-intercept is up 1, so I would just say plus 1. Donezo with that one. Okay, number 2, our job is to graph this equation. So this time I'm giving you the equation. We're going to put it on the graph. This equation's already in y equals mx plus b form. The y-intercept is 1, so I'll plot that. And the slope is negative 1. And to plot negative 1, that's just really 1 over 1. In other words, the rise and run are equal. So I also need it to be negative. So I'm going to go down 1. I could go up 1, but then I'd have to go over this way to make sure it's negative, or I could go down 1 and over 1. And either way, I'm going to get a bunch more points, and then I'm going to draw my line all the way through, make it a nice, neat line, and we'll be done with that one. All right, let's go down to number 1 on the bottom, and this equation is of a different form. This is called standard form. And there are two ways we can graph this one. I'm going to go over both ways. First way is we can use an x and y intercept. So an x to y intercept just means that the y-intercept is when x is 0, the y-intercept is when y is 0. So I'm creating coordinates here. So this is 0, and I need to figure out the y. And the y is 0 in this one. I need to figure out the x. Let's talk about a shortcut for that. 0 is my favorite number because 0 times anything is 0. So when I plug in 0 in for this x, 2 times 0 is going to be 0. I can basically just cover this up because it's equal to 0. I don't need it. And I'll be left with negative 3y equals 6. I would divide by negative 3, and I would get negative 2 for my y. Now for this one, I'm telling you the y is 0, and we need to figure out the x. So I'm going to plug in y is 0, which means I'd cover this up. I'm covering it all up for you. And I would have 2x equals 6, and then divide by 2, and I would end up with 3. And then now I have two coordinates. Here's the y-intercept is negative 2. Here's the x-intercept is a positive 3. And once I have 2 points, that's enough to draw my graph. Okay, another option would be to take this equation and turn it into y equals mx plus b, because we're familiar with how to graph that equation. So to do that, I'm going to subtract 2x. And this negative stands, so I'd have negative 3y is equal to 6 minus 2x, because these are not like terms, I can't put them together. Let's divide by negative 3. This guy goes nighty-night. And I get y equals, now the key is I need to separate these out because this is not in slope-intercept form. So I would do 6 divided by negative 3 is negative 2. This negative negative is going to be a positive, and I would have 2/3 x. And I should get the same thing when I graph this. So I'd have y-intercept of negative 2, excuse me, and then my rise over run is up 2 over 3, so I'll get the same line either way. You can choose how you want to graph that. I just want to give you a couple options. Okay, in letter B, I don't like the way this looks, so let's rewrite this in a better way. To rewrite this, I would distribute. So I would have y minus 1 is equal to 3x minus 3 plus 4. I got some like terms over there. Y minus 1 is equal to 3x plus 1. Let's add 1 to both sides, and I get y is equal to 3x plus 2. This is in y equals mx plus b form. Now I can put that on the graph. I'm going to let you do that. Let's go to the back side. I have some different special cases here. First of all, this equation says x minus 3 equals 1. I don't really like how that looks. What I would do is I'd add 3 to each side, and I'm going to end up with x is equal to 4. And I know how to graph that. Where does x equal 4? Well, right there. But x also equals 4 here, here, and we should know that x equals 4 is a vertical line because everywhere on this line, the x value is equal to 4. For letter E, my only hint to you is I would solve this equation for y. So I would rewrite this equation in a way that I'm going to get y equals mx plus b. So I'm basically solving for this y. So step one I would do would be to add 12. And then I'm going to let you go through the rest of that one. Let's go down to number 2. It says, what is the equation of the line that goes through coordinates -1, 2 and 1, 4? So we're writing an equation. And I'm going to try to write my equation as y equals mx plus b. We know m is a slope, and we know how to find the slope from 2 points. So slope would be y2 minus y1 would be -4 minus 2 all over 1 minus -1. This is going to give me -6 over 2, which would be -3. So my equation right now looks like y equals -3x plus some sort of b value that I don't know yet. So I don't know what this b value is, but I can get an x and a y and substitute in. And the place I can get that is from these coordinates. These are both, this is an x, this is a y. So I'm just going to choose this coordinate. I'm going to plug this in for the x. I'm going to plug this in for the y. So I would have 2 is equal to -3 times -1 plus b, which is good because I want to solve for b. So 2 would be equal to, this will become a +3 plus b. Let's subtract 3 from each side, and I'll get -1 is equal to b. And then I'm going to substitute that back in. So in the end, my equation is y equals -3x minus 1. Donezo with that guy. All right, let's go down to number 4 and look at the table here. So the goal is to write an equation from this table. For the equation, I'm going to write it in y equals mx plus b form. So I'm going to need a slope from a table. We know how to do that. And I'll need a y-intercept, and we'll talk about how to find that on the table. First of all, our slope, this is going to go +2 for the rise. This is going to go -4 for the run. So my 2 over -4 is going to be -1/2 when I reduce that. So I know my equation is going to say y equals -1/2 x. Getting excited and breaking my lead. And then I need a y-intercept. Well, what's a y-intercept? It's the y value when x is 0. So when this x is 0, it looks like the y value is equal to 2. So I don't have to do any calculating. So this would just be +2 on the end. And likewise, here's a y-intercept. That actually has a y-intercept of 2. This has a y-intercept of -2. All right, let's check out number 5. So for number 5, it says, in a coordinate plane, which of the following are located on the graph of y equals -2x plus 3? And we got to tell whether or not these are on there. One option would be to graph this line and see if these coordinates fall on there. Another option is to plug these coordinates in. This is an x, this is a y. So I'm going to plug those in and see if it makes it true. So -1 for y. So -1 equals -2 times 2 plus 3. So I get -1 equals -4 plus 3. -1 equals -1. Okay, and then we're going to put a smiley face. So what does that mean? This equation made this statement true. That means this one is on the line. And what you're going to do now is plug these in and see if these are on the line. So you have to test all of the points and see if they're on the line. Let's go to the back. And let's do letter A. So in this one, I give you a series of graphs, tables, and equations, and we need to match them. So we're going to match graph A with a table, one of these, and we're going to match it with an equation, one of these. Well, first of all, we can just pick some points out here. So like this graph right here, 0, 1 is a coordinate. Let's see which ones have that. This one has 0, 1. This one doesn't. It has 0, 0. So this one's not B. That doesn't work for that one. This one doesn't say, but that's okay. We just can't eliminate it. This one doesn't have one either. But then I also know it has a slope of 2 over 1. So I would need to find one with a slope of 2 over 1. Well, this one looks like it has a slope of 0 because this rise is 0. This one looks like it has a slope of 1 over 4. Actually, -1 over 4 because this is -1 here. This is +4. This one has this undefined slope because the x's are the same. And then, so I guess that leaves really this one. This one has a slope of, this will be 10, negative 10 over, and this will be negative 7. And that doesn't look like that's going to work for that either. Let's check the slope on this one. It might be a mistake on this one. So this is going to be plus 2 over plus 1. So I must have a mistake on these points right here. So letter D is going to be the correct answer for this. And let's check another coordinate. It says like 1, 3. 1, 3 is right here, over 1 up 3. So it is letter D for the table. And this coordinate must be a mistake. Or one of these coordinates is a mistake. All right, so anyways, let's do the equation. Well, the equation's easy. This has got a slope of 2, a y-intercept of 1. Which one has a slope of 2 and an y-intercept of 1? Certainly not this one. This is a vertical line. This is a horizontal line. This one, if I divide it by negative 4, is going to give me y equals negative 1/4 x. So it's got to be this one right here by process of elimination, and we could solve for y and figure out that that was the same equation. So that one's going to be number 4. Okay, that is all the examples for GRE 503. Go ahead and finish up the rest of those, and let us know if you have any questions.